Let's say that we have this problem, 2 and 1/10 of v, and we're going to add 1 and 3/10 of v to it. And so before we even start, I'm going to kind of recommend that if you say 2.1 or 1.3, that you're not helping yourself when it comes to making sense of the problem. And here's why. When we actually look to see what we have, and so if we have 2 and 1/10 of v, so meaning where this tells us, this 2 and 1/10 tells us the number of groups. And so we can make sense by it thinking, well, if I have two whole groups of v, we can visualize that by drawing two groups of v. So there's one group and here's two groups. So there's v and there's v. And what we can do is now we can look at, well, now I have 1/10 of a group of v. And so we need to go ahead and represent our last group of v, but this time, since we don't have the whole group, we can imagine that, well, we can split this into 10 equal slices. So there's 2, 3, 4, 6, 7, 8, 9, and 10. And where one of these little slices is 1/10, or we could say 1/10 as a decimal. And so now what we can do is we can look at, well, what are we going to add to this? And we're going to add one whole group of v and 3/10 of v. And so we can look and we can go ahead and let's go ahead and visually see us adding a whole group of v. And now we can go ahead and add 3/10 of v. And so here is our 1/10 from our what we started with. I forgot to shade that in. And now we can go ahead and shade in 3 more tenths. And what we see is that, well, how many whole groups of v do we have? We see that we would have 3 whole groups of v, and we would have 4/10 of another group of v. We can also use the same concept if the problem is asking us to subtract. And again, if we can get away from saying 2.1v minus 1.3v and think of it as 2 and 1/10 of v, and we're going to take away 1 and 3/10 of v. It's just going to help us kind of make sense of what we really have. And so what I'm going to do is I'm going to go ahead and represent, right? So when we have this 2 and 1/10 of v, we see first that, well, we're going to start out with 2 whole groups of v. So here's one group, and then here's 2 groups. And so we're going to represent that this whole thing is our number v, and this is our whole number v. So now I have 2 whole groups of v, and just like the last problem, we have another group, but we don't have a whole group. We only have 1/10 of it. And so this would represent v if we had it, but now we can go ahead and cut it into 10 slices. And we can go ahead and shade in 1/10. Now we can look at what is the problem asking us to do. Well, first we can look at it as, well, we have to take away one whole group of v. So let's go ahead and take away a whole group of v. So I can do that by just eliminating it, crossing it out. And so right now we're still left with one whole group of v and 1/10 of v. And so now we need to take away 3/10 of v. So we could look at it as one whole group and 1/10, but we can also now we can manipulate this group of V, while this whole thing still equals V, but now we can cut this up into 10 equal slices as well. And now, just like this piece down here represented 1/10 of V, each of these slices for this whole group that we have, each slice is still a tenth. And now we can look at that. What we really have would be, we could see that we have 11 tenths of V, and now we just need to take away 3/10 of V. And so here I took away 1/10, here's 2/10 and 3/10. And what we'll see is that we're going to be left with 8/10 of V. And we can obviously see that, well, we got rid of this whole group, and we got rid of this tenth, and we got rid of 2/10 of this group, and so we don't even have a whole group left, and which is exactly what this means by when we say 8/10 of a number, which is just V, which we don't know what that is. Well, we can make sense in our mind that if I have 8 out of the 10 slices, I don't even have a whole group. Where when we say 0.8 or 0.8 V, it doesn't help us make sense of what it is that we really have.